Alright, the next part of chapter 1 is the states of matter. So we've talked about these ever since we were in 4th grade. Or you and your teachers have, rather. So this is mostly a review. The solid is the first state that most of us talk about. Is the state of matter that cannot flow and has a definite volume and shape. Your table's top's a solid. The vehicle you drive is definitely solid. The liquid has a definite volume, but no definite shape. It can flow. Gas is a substance with neither definite volume nor definite shape, and gases can also flow. The fourth state of matter, rather, that you probably rarely talk about is plasma. And that's just high energy gases. And you see a lot of light associated with it because of the electron movement. We'll talk about electron movement and then the energy associated with it a little bit later. Alright, so we have a little chart here. Solid. Does solid have a definite volume? Absolutely. Liquid. Can we measure the volume of a liquid? Absolutely. We can use that with a graduated cylinder. What about a gas? We can measure the volume, but gases can be compressed. So, we do not say they have a definite volume. Solids definitely have a definite shape. If you think of your tabletop, it's kind of difficult to change that amount of matter into another shape easily. Liquids can flow. They can take the shape of their container just like gases can. Let's think about particle position and movement. Solid, they're packed tightly and they're constantly vibrating around a fixed point right next to each other. In a liquid, they're close together, but they flow past one another and they kind of move. In a gas, they're very far apart and they're rapidly moving everywhere. They can flow as well. A physical property is a property that can be observed and measured without changing the identity of the substance. Examples of that would include the boiling point, the melting point, the mass, the volume, its ability to conduct electricity, its color, its appearance. A chemical property relates to a substance's ability to undergo changes that transform it into different substances. So examples of that will be reactivity, its ability to react with a certain chemical like water, its ability to react with chlorine, its ability to react with air. So reactivity is chemical properties. Chemists use properties to identify and separate matter. More than one property must be used for identification. An intensive physical property or an intensive property does not depend on the amount of matter present. Examples that would not depend on the amount of stuff there would be melting point, because no matter what the melting point is of a substance, it's always going to be the same. The boiling point is always going to be the same. Density is always going to be the same, and the ability to conduct electricity is going to be the same. It doesn't depend on how much stuff's there. It's always going to be the same. Think of a block of gold. A color will be another example. No matter how much, whether you have a gold ring or a gold bullion bar from like Fort Knox, it's still going to be about the same size. An extensive physical property does depend on the amount of stuff there. So think about mass, volume, anything that depends on the amount of stuff present. Changes in matter. A physical change does not change the identity of something. Example of that would be a phase change. If you go from solid to liquid, it's still the same, but it didn't change the identity of it. Boiled water, when you have liquid water going to gas, it's still the same. So boiled water is still water. All phase changes are physical changes. Another example of a physical change would be if you cut something up and divided it out. It's not changing the stuff there. It's just, or not changing the identity of the stuff. It's just changing like how much stuff is there. All right. If we go from solid, we have three. Here we have a model. We have three beakers, if you will: solid, liquid, and gas. If we go from solid to liquid, we consider that change melting. liquid to gas, we consider that evaporation. If we go back the other way and go from gas to liquid, that's called condensation or condensing. If we go from liquid to solid, that is called freezing. If we go from solid straight to gas, that is called sublimation. And if we go from gas to solid, that is called deposition. Sublimation is a process in which a solid changes directly to a gas without going through the solid phase. An example of that is iodine will do that. Also, CO2, carbon dioxide, or dry ice. If you have a piece of dry ice just sitting there, it'll go straight from solid to gas. A chemical change is a change that occurs when one or more substances are changed to completely new substances. And you can typically write a chemical equation for a chemical change. In a chemical equation, you have reactants, which are substances that react, and products, which are substances that form. Products have completely new and different properties from the original. Indications of a chemical change. There are 5 indications of a chemical change. The first one is the production of heat, light, sound, or electricity. The second is the production or evolution of a gas, little gas bubbles forming. Third is the formation of a precipitate. If you think of precipitation when you have stuff falling down, like from the sky, water, snow, in chemistry precipitation, you typically have 2 liquids mixed together and a solid falls out. A change in color or a change in odor. In separating mixtures, we separate mixtures by their physical properties. There are 4 primary methods of separating mixtures. They are filtration, distillation, centrifuge, and chromatography. And we will do most of these this year, except for the centrifuge. We don't have a centrifuge. Filtration is a method used to separate the components of mixtures that contain an insoluble solid, meaning it does not dissolve in water, and a liquid. So, for example, I've got sand and water. We could use a funnel with some filter paper to separate sand and water. The sand does not dissolve in water, therefore it remains in the filter paper, and the water will go through the funnel. That we call it filtration. Another example of filtration is if anyone makes the coffee in the morning at home, you have the coffee filters in there, and that keeps the coffee grounds out of your coffee, because coffee grounds are insoluble if you've ever had any in your coffee. Distillation is a method of separating substances in a mixture by evaporation of a liquid and subsequent condensation of its vapor. For example, if you have watched Survivorman, he will sometimes make what he calls a solar still. There's a couple different ways to do this. You can take salt water and use this solar still to have the water heated up, and then it condenses back, usually on a plastic bag, and he'll collect that water. And what it does is it brings the temperature of the water up, so the water evaporates. Then it cools it back down, and it's free of anything that may have been contained in it beforehand. You're playing with the melting points, or the boiling points rather, of these different substances, their different physical properties. Centrifuge. It's used to separate solid liquid mixtures such as those in blood. The centrifuge uses centrifugal force to spin rapidly around, forcing the heavier stuff to the bottom, liquids on top. An example, if you've ever seen like a hospital show and they've got blood and they've got it spinning, trying to force those platelets out to the bottom. Chromatography is our last method of separating mixtures. It's used to separate a stationary phase and a mobile phase. Paper chromatography is the one you typically see in high school. It's used to separate pigments because they move at different rates on paper. You probably did this in junior high. You put a dot on a paper, put it in some liquid, and it crawls slowly up there, and you have like a little rainbow. There are many different types of chromatography, especially in biochemistry. You've got column chromatography. You've got gas chromatography, which is an analytical method using instrumentation. That's pretty cool. Just several different types of chromatography. And that does it for separating mixtures and phases.